Hi everybody, welcome to Deep Cleaning Day. Today we're going to be doing some notes and completing some questions. Alright, so by now we should be pretty familiar with what the midpoint formula is, so I'm just going to breeze through this one kind of fast. If we want to find the midpoint of two endpoints, we need to use our formula. Basically what we do is we add our x's together and we divide them by 2. So I'm going to do that. 3 plus 2 is 5. Divided by 2, right? Negative 4 plus 7, that's a 3 divided by 2. All right, and then we just simplify this to where it's a decimal, and we get a midpoint of 2.5 and 1.5. That's our answer for the first one. All right, if you don't know the midpoint, go back and look at your notes. They're on Google Classroom. Now it's your turn to find the midpoint of the line segment. All right, here's your points. Go for it. Now you guys have had some time to find the midpoint. Let's do one with a graph. If you really struggle with graphing, you need to come to my tutorials and I'll help you out. But this point right here is 5, 3. All right, so we've got 5, 3. We also have the point over here at negative 4, negative 1. Negative 4, negative 1. All right, so I'm just going to rewrite these over here. We've got 5, 3, and we also have negative 4, negative 1. All right, so for the midpoint, we should know by now that we need to add our x's together and divide them by 2. So midpoint, we're going to add those x's together. I'll show all my work this time. 5 plus negative 4 divided by 2. All right, and then we've got 3 plus negative 1 divided by 2. All right, let's go ahead and simplify that. 5 plus negative 4 is just 1 divided by 2, comma, 3 plus negative 1, that's 2 over 2. All right, we simplify that a little bit further, and we get 0.5, comma, 1. All right, that's our final answer. So that's how you would do it from a graph. Same concept, just you have to be able to identify points. This next example is for you to do. Go for it. All right, now you've had some time to find that answer, hopefully. The next one, so let's see, this was something new that we did yesterday. So we're given an endpoint and we're given a midpoint, right? So we learned the long way and we learned the easy way. Now the easy way, which most of you guys preferred, was to figure out how far do I go down and over to get to the midpoint. And then from there, we do the same amount down and over to find the missing endpoint. All right, so I'm going to zoom in on my screen. Get a little bit closer so we can see, okay? So let's go down and figure out how many. Okay, so we've got to go to here. Let's see. 1, 2, 3, 4, I believe. Yes. So we go down 4. We have to go right a whole bunch. Well, that's a lot of numbers to count. We can count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's 9 from, here to the y-axis. And then we go over 10, right? So 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so this whole thing here, I'm just going to do this. We went to the right by 19, all right? I knew that because negative 9 is 9 away from the middle, right? And then 10 is 10 away from the middle. So, 9 and 10 is 19. So now we got to do the same kind of thing and go over 19 and down 4 to find the other midpoint. All right, so let's go down 4, 1, 2, 3, 4. And we're going to go over 19. 1, 2, 3, 4, 5, 10, 15, 16, 17, 18, 19. All right, so let's figure out where that point is. All right, so it looks like it is at positive 29, comma, negative 1. So that is our second endpoint, which makes sense because it's about equal distance from the midpoint. And I'll make a little line here so you can see what it looks like from endpoint to endpoint. All right, now it's your turn. All right, this next problem is for you. I will move this down so you can see it. Find the missing endpoint if you are given the endpoint and the midpoint. Now let me zoom in for you. Go for it. Okay, now you've had a minute to answer the question. We're going to go over something new. It's called distance formula. All right, so first I'm going to show you what the distance formula is, but before that I want to talk to you about Pythagorean theorem. This is something you guys went over, I believe, in middle school. All right, basically what Pythagorean theorem said is if you have a right triangle, it's like this, right? And you have a side A, B, and a hypotenuse C. Remember this from middle school? And it said A squared plus B squared equals C squared. Well, it's the same kind of concept. This is where it comes from, the distance formula. I'm going to scroll down and show it to you. All right, so I'm going to show this distance formula to you, and then I'm going to scroll back up and show you how to find the distance on the Pythagorean theorem. All right, so let's just count. How big is A? So 1, 2, 3, 4, 5, 6, 7, right? We've got 7. All right, so 7 squared plus 1, 2, 3, 4, 5, 6. B is 6 units long. And then we're going to end up with C squared. This is how we're going to find our distance. Now, bear with me. This is 49 plus 36 is equal to C squared. All right, so 49 plus 36. I don't have my handy-dandy calculator, so let me just do that real quick. 49 plus 36. I'm trying. 49 plus 36 is 85. Okay, so let's go back to our notes. 85. So we've got 85 is equal to C squared. All right, so now we square root this guy. Okay, so let me just, I like my C on the left side. C is equal to 85, or C squared. We have to square root both sides. Square root. C is equal to the square root of 85. Now remember at the beginning of the year when I showed you how to simplify radicals, we have to break this guy down into, the prime factorization, the prime numbers, right? All right, so we could do 5 times, let's think about it. 5 times 20 is 100, 5 times, 19 would be what, 95? So 5 times something is 85, all right? So what we're going to do is 85 divided by 5, 85 divided by 5, and that's 17. Now 17 is a prime number, and actually 5 is a prime number. So since we can't simplify it any further, it just stays as it is, the square root of 85. And that's our distance for that line there, okay? So you don't know what you just did, but you just did distance formula. You don't even know it because we looked at it as Pythagorean theorem. If you take a look at the distance formula, it looks very similar to it. Really, it's kind of like saying, let me do it in this same color, like above. Like above where we said C is equal to the square root of, A squared plus B squared, right? It's the same exact thing. Only we're going to be using the points to find the distance formula. So you can either use this distance formula, which is very similar to our midpoint. Remember, we label one point x1, y1, and the other one x2, y2. Or you can use that Pythagorean theorem that I just did up here. All right, it's going to give you the same exact answer. So there's two different ways you can solve it. And I hope you're taking good notes because you're about to have another example. All right. For this one, though, it's just a straight line. How do you find the distance of a straight line? You just count. So 1, 2, 3, 4, 5, 6. So the distance for this one would just be 6. So anytime you just have a straight line, all you do is just count it. Okay? Write that down. All right, your turn. You can either use the Pythagorean theorem here, or you can use the distance formula, which let me copy it and paste it down here so that way you can see it. Now, I personally would use the Pythagorean theorem, but let me show you real quick. Let me just help you out. This is the point 3, -5, 3, -5. And this one's -2, 0. -2, 0. Okay. This one's going to be x1. x1. All right. y1. Just trying to help you a little bit if you want to use the distance formula. And then we've got x2. x2. And then one last color, let's do blue, y2, y2. All right, so you can use that distance formula right there, or you can use Pythagorean theorem. Go for it. All right, so now you've had a minute to work this out. If I were doing Pythagorean theorem, this is what I would do personally. I would draw a line here and draw a line here. I would count out my units here, and do Pythagorean theorem to get that hypotenuse. But that's just me. If you do the distance formula, awesome. We're going to go over some more of that next week. All right, here's another example for you. Go for it. All right, now you guys have had some time to work on some problems. Here's another really easy one. Remember, if it's just a straight line, count. Just count how many units. Go. All right. And last but not least, I'm going to work on this one really fast. This one is x1, y1, x2, y2. I'm going to paste my formula here. And I'm going to work it out really quickly for you. All right, so distance is equal to, all right, x2, that's -8 minus -10 squared plus y2 minus y1, so that's 1 minus -7, right, squared, all under this big square root symbol. All right, so two negatives, that changes to a positive. Let's simplify. -8 plus 10, that's going to be 2 squared. I'm running out of time here, I gotta hurry. 2 squared. This turns into a plus as well. 1 plus 7 is 8 squared. All right, then we end up with 4 plus 64. All right, and that is square root of 68. We can see if it simplifies. Let's think of some numbers. This is obviously divisible by 2, so you could do like 2 and 34. 34, you could do 2 and let's see, what is that, 17? All right, we have a pair of 2's, so we pull that out. Pair of 2's, so we pull that out. And we are left with 2 square root 17. All right, so it's very important that we learned how to simplify those rational numbers. All right, and let me move this down a little bit. And this one is your problem now. All right, so go for it. Tell me what you get. All right, so now you've had some time to work out some problems. I will see you guys on Monday, and we will go over distance formula again. Enjoy your day, guys.